Hi, this is the fifth video on the Zookeeper series of the YouTube videos. So in this video, we are going to discuss one of the very important concept and that is for Zookeeper has been developed, right? So how you can establish the coordination if you have the multiple worker nodes in the distributed system. Uh, in other words, if you have the bigger tasks and you want to divide those bigger tasks into the multiple nodes, how you can divide and how all the multiple nodes work in the syncing so they can avoid the duplicate kind of effort, right? So let me understand with the use case. So, and this is very common use case you might be encountered during the many enterprise development project, right? So suppose if you have one database and in database we have the one table. Suppose this is the database, right? and and in database you have the multiple job information you can see that started from 1 2 3 4 go to the 10,000, right? Suppose you have the 10,000 jobs and you want to execute 1,000 jobs or 1,000 tasks. Each batch means each time you want to execute the 1,000 and you want to execute this 1,000 jobs into the 1 hour time. But when you do this 1,000 tasks by the one machine, one node, one virtual machine, they are taking the 4 hours time. So what you will do? So if you suppose you are giving these tasks to the one worker node, it is taking the 4 hours times. So what you will do? It is not going to achieve our purpose. So what we will do? We will add the multiple worker nodes. So suppose we add the worker node 1, worker node 2, worker node 3, and worker node 4, right? And the moment you are adding the multiple worker nodes to implement some kind of the activity, that system is called the distributed system, right? So this is called the distributed system. And this is called the horizontal scaling, right? We have already discussed in one of the video. So this is called the horizontal scaling. Means suppose you want to achieve this task in 1 hour. So you add the 4 machine. If you want to achieve this task into the half hour time, so you can add another 4 machine. So you can horizontally scale this system. So what happened that then all the 4 machines will connect the database and they will take the task and they will start that, right? But it is not way of working because which range of the task they will take, right? So you want to specify that this one worker machine take the task from 1 to 250, right? And this machine should take the data from 251 to 500, and this should take the 500 to the 750, and this should take the 750 to the 1,000, right? To avoid the duplicate of kind of things. So where you will save this information? So of course you will save this information. This is the hard code, right? So either you can do hard code in each machine, or you can use some configuration file to maintain this information, right? So then it will start work because in this configuration file, this machine configuration file, the range is 1 to 250, right? So they will go the database and pick up from 1 to 250 range and they will start executing that. So far, so good. Let me now give the problem here. So suppose your one system get down, then you have to monitor. So what is the problem here? You have to monitor first if any node if any node gets down, right? Then again you have to change this range because one machine get down, right? So it will again you go and change 1 to 333, then 334 to 6 something, right? 666 kind of things, right? Or another case, if you add one more machine, this machine 4 machine was there, you add the one more machine, then in this case again your range will change 1 to 200, and this last will be the 800 to the 1,000, right? If you add the one more thing. So again monitor if any node added, right? In both case, always you have to change the configuration, right? So you have to monitor first. After monitor, this is the one problem statement. So every time change configuration file, right? This is a problem that, so that's why it, this solution will not work. So you cannot add any kind of the node, any number of node. Auto squaring you cannot do that, right? So suppose if you want to add 5 and 6 machines, you can't add, right? So this solution will not work. So what we will do, we will use the some coordination system, and that is called the zookeeper. So what we will do, add one zookeeper here. Zookeeper server or Zookeeper cluster, as per your requirement, you can take it, right? Considering this is single point of failure is not there, we have the multi-cluster database, and you know also the Zookeeper is also there is no single point of failure, right? Now, what you will do, uh, we this all the worker node will subscribe the Zookeeper, and we have already discussed that how it will subscribe. And first, if any worker node, the first worker node or any worker node is going, first they will create one parent Z node. So this is the persistent Z node. Suppose you give anything name, DB or something, persistent node, and you know the what is the persistent node? It will be the persist. It will not delete anything even though system is the deleted, right? This is the parent node. Consider this is your parent node or root node, right? And now, and put some data here. So put the data 1000. When you will create this node, so this is your, this is your key and this is your value, right? For the parent node. And whatever the child node, whenever you add any worker node, they will subscribe. They will create one child node. And this is your child node of parent node. Parent node is the DB. And this should be the important thing. This should be the ephemeral node. And you know what is the ephemeral. So this is the persistent Z node. This is the ephemeral node. The benefit of the ephemeral node is that whenever this worker node is get down, automatically this node will be deleted. Right? No need to put any value. Just uh, create the name, create the ephemeral node, and the name, the key of the node is the UUID. So DB is the parent, and here is the UUID. In the actual scenario, that should be the IP address, but I am going to show the demo in the one machine, so I will not have the multiple IP address. Instead of that, whenever this worker node is subscribed to the Zookeeper, you create one UUID and make the child node of the UUID. The same thing, when this node be created, they will create one node with the DB. This DB is the parent node name and their UUID. The same thing for the third worker node, same thing for the fourth worker node. So this is the structure for the J node, what you're doing that. Now, what is the benefit of this? Benefit of this, and you have to create some watch that we have already discussed in the previous machine. So this parent node, right? On this parent node, configure some watches. Two kind of watch. One is the data change watch, means if any time if I change this value 1000, that notification should come. And second watch, if anything children change, that I will show the exact in the code. So anything in the children change means if adding new children or removing any children, those both time you should have the callback notifications through the watches, and and if any change in the parent node value, then you should do that. That job is done. Let me show through the code how it will work, right? So here we do have the one callback method, right? You can give any name for the callback method name, and this method will be calling by the zookeeper on the each machine in the two scenario if any value either value is changed for the parent node, this is your parent node, or if any number of children has been added or deleted. In both cases this callback method will change. So what you will do whenever the callback method will be execute, first you fetch all the children, so all child from where, so zookeeper dot get children with children db, so db is the parent, right? And make the watch is equal to true. Why you making the, this is the watch, right? Why you making is equal to true? Because our watch is the one time operation. So to make the watch always working, so I have to put the watch here. And whenever the callback method come for the previous watch, again they will create the new watch. That's why I make the true here. That I have already explained in the previous video, right? And now this is the one thing. And second thing is that get the data means this data. So for the time being, we can say means what I was talking. I was talking this 1000. I want to execute 1000 number of tasks in one batch. But this 1000 should be also the configurable, right? So today, as per the use case, I want to execute. I want to execute the tasks in the multiple of the 1000. Tomorrow you want to execute the task multiple of the 2000 or 3000 or the 500. So you should not change the code anywhere. The moment you change this data parent node value, automatically it should be adjusted. That I will explain you. So for that you should take this number of tasks, right? Number of tasks. From where you get the data. So again zookeeper get data from db. And some parameter is there. Okay, now you have the two value. Third value, each node task. Okay, so suppose 1000 is there and you have the 4 worker node. Okay, how you will get the how many system is up right now? So n is equal to number of child. So this if you do all child dot size, it will tell you how many childs are there. So when you run the first worker node, the value would be 1. When you add the two worker node, because the both worker node has been created the two ephemeral child node, so this value would be 2. So you can say the tasks per node. Total is 1000. 1000 is number of tasks. So number of tasks divided by number of child. So you will get that number, right? And you have to start the tasks from 0, right? So what is the range for this one? It should start the range, ending range. So tasks per node plus start means this is the 0, this becomes the 250 if they are the 2 worker node. So 0 plus 250 plus 0, so this will make the 0 plus 2 from 0 to 250, right? Now you make one the for loop and iterate for how many child we have, right? So you can say child or child, and then you can assign these tasks that I will explain you. Now the benefit is that whenever you change this database value, again this call be method will execute. They will take the 1000, 2000, they will take the number of children and they will divide. So suppose starting if you have the 1000, this value, worker node is 2, then they make the two range. One range from 0 to 500 and second from 500 to 1000. Keep the 1000 same, no need to change anything. Add the two more node. So this automatically will change the range from 51 to 750 and 750 to 1000. That I will show in the code. Now suppose make the 2000 with the same 4 machine. You can see it is automatically going to change according to the number, right? So 7500 to the 2000. So in short, the magic thing is the only two thing magic is that whenever node is created, check if this parent node is there or not. If it is not there, create the parent node and the create the inferior node. That's it. And once the you will get the callback method, you have to put some logic how you distributed the tasks. That's it for this video. Let me show the code. From the code, you might be get the better understanding. This is the complete code. So we have one Java class worker node, and if you run this program for the 4 times, it will behave like the 4 different node, right? So when you start, as I discussed, we fetch the UUID. So each executions we have the one new UUID to represent the individual machines, right? And then we add the watch on the two things. If any node value change for the parent node or anything change in the children node, if adding or deleting any children node, right? In both case, I will call our callback method, that is called the distribute work, and we pass the UUID and the root name that you can do any logic. So once you set up the watch, we create the Zookeeper object and we have to pass the IP address for the Zookeeper. We are running in the local machine, so this is the local host 2181, and then you have to pass the watcher, the same watcher what you have created here, right? And as I discussed, so create one root node. I have given the root node is the DB. If DB is not there, not exist, then create that, but it should be the persistent. This is important thing here, right? And just log what is the machine ID. And then as I discussed that, so when you create the worker node, you have to create one child node, right? So we are creating the child node. So this is a parent node, and backslash and give this name. Just prefix the worker node and the UUID, right? Now, no need to pass any data. You can pass the empty data also. We are not fetching those things. And this should be the imperator, right? Imperator, sequential, or imperator, anything you can use that, right? So even imperator is also okay. And then first time when you execute, that might be your callback method will not call, or you can just check it. It could be called, could not be called. You can just check it. And that's why just for the safer side, I have call this distributed one more time. And then make this thread open for the longer time, because this is not the Spring Boot application, this is Java based application. So it should be for the demo purpose, it should be the show always, right? It should execute always. What we are doing the callback method, that is important. So first we fetch how many childrens right now we have. What is the configuration data, right? This is the configurable data. So 1000, 2000, what I kept right now, that we kept in the parent node, right? So if you see here, when we created the root node, I passed the 1000 value for the time being, but later you can change through the command and argument also, that I will show you, right? And then we fetch the number of tasks, right? So what of the configuration we have, and then number of children. So suppose if you have the 4 worker node, so each worker node, how much portion they will have, so total number of tasks divided by n, right? And then you can start from the 0. Here what you are doing that, so once you get all the children here, then we will, this is the main logic. So we will doing the what is the start and what is the portion, right? So start, first time it is start 0, second time start with the portion plus 1, and the start also. So for the confusion, let me more start from. So suppose first time start with the 0, right? And then from 0 to portion. Next time start plus portion plus 1. So so first time 0 to 250, next time from 250 to that number, right? That's why this logic is there. And if this node, if this is your node, because they will execute this method for all the worker node, right? So if your node name match with this child, so you will get the log that what particular machine, what is the range would be there. So let me show run the code, but before run the code, we should run the to Zookeeper. So let me start the Zookeeper. We have already discussed how to start and all those things, right? So start the Zookeeper. So if you see here, so Zookeeper is started, Now, okay, that's it. Now let me start the server client also from here, right? So Zookeeper client. And just I want to show you if uh, what are the different parent node here. So we don't have the DB at all, right? So now let me run the first means let me run the first worker node. So if you see here, my worker node is the worker node in the database, in the code worker node, and this is the package name, right? So this is the way to run the your Java class. So I started it. I have kept four things, so you can easily see that, right? It's running. Now you can see what happened. First come here, they might have created one parent node DB. Now it is working. Now let me see, they might have created one parent node with the name of DB. You can say this DB has been created, right? And one child should be also there in the DB. So how you will do that? So if you do this command, you can see one child has been created, right? And that's why it is showing number of children is equal to 1, and the configuration number is 100,000, right? So when the first time when you run, we have already given the 1000 values here the first time. Okay, now move here. So okay, the one working node is there, so the range is the 1 to 1000. Run one more worker node. Now you can just keep your eye here, that number should be changed. Now it is showing the worker node 2. So now we have two worker node. So one worker node this one, and second is this one. So first worker node, they give the range from 0 to 500, and second to the 500 to the 1000. You can just change the code to make the 1000 here. Okay, now do one thing. Now add one more node. So when you add the node, now you can see here it becomes the 3 now. Now work connected is the 3. Every all the worker node is showing the 3, and range is also accordingly to they have changed, right? So from 0 to 330, 334 to 667, 668 to the 1000, right? So we can do that. Now do one thing, make the get down one worker node. So delete the one worker node. I'm doing the control C. Now you can see the moment we delete the worker node, the automatically they change the number of worker node is 2, right? And then again they reconfigure the number. So this is 0 to 500 and 500 to the 1000. This is how it is working. Now let me show you if I change the configuration number from 1000 to 2000. Keep the machine working node 2 only, and from here, from the server directly, we can change. You can say it db, this time I am value the 2000, right? So I'm making the 2000. So now you might have noticed that this number is already this is the dead worker node. So it is here worker node, this 1 and 2, their number has been changed. Now number is become 0 to 1000 and 1000 to the 2000, right? So now if you start the third one also, so again that number would be changed accordingly. So now see, this number is changing accordingly, they are changing the number. Even though if you add another one more, so now they are changing that. So in this video I showed you how you can making worker node with the dynamic configuration, and how to divided the resource forward to complete the one big task here, right? So, and all the code base I have given into the GitHub, that I will share those link here, right? And even if you want to go the GitHub, I can try to show you fast. So GitHub, go here, Binod Suman, and here you have to come to the Zookeeper things, Zookeeper, and the distributed worker node, right? So Zookeeper demo, it was there, and they distributed here. So this is the complete code, this is what I was discussing here, right? Thank you very much. Please don't forget to subscribe this channel and share this information with your friends. Okay, thank you.